Hi students, in previous class we saw about what is a half-wave rectifier, what is rectifier and what are the two types of rectifier, which is half-wave and full wave, and what is filter, how to filter the ripple noises with the help of capacitor, and also what is load resistance, and what are the basic formulas we have been collected. In today's class we are going to see about what is half a full wave rectifier. So which type of rectification is used to convert DC and AC conversion is something that half wave rectifier, and full wave rectifier, which is more efficient, means full wave is more efficient compared with the half wave rectifier. And so we are going to see about what today's topic is about: definition and full wave rectifier circuit and working of full wave rectifier and its formulas and also advantages and frequency. So here the full wave rectifier. Full wave rectifier is something that it is defined as a rectifier that converts a complete cycle of alternating current into a pulsating DC, which converts a complete AC input into a pulsating DC output to utilize both the positive and also a negative half cycle. And so unlike half-wave rectification, the utilization only half-wave of input AC signal, where here full wave has been utilized, and lower efficiency of half-wave rectifiers can overcome with the help of full wave rectifier. So where both the positive and negative half cycle has been used. So the arrangement is known as center tapped full wave rectifier. Here the second method uses a standard transformer with four diodes to arrange as a bridge, that is known as a bridge rectifier. So here you can say the circuit of a full wave rectifier can be constructed with the help of two ways. The first method is about center tapped, and the second one is about two diodes. So center tap is something that two diodes are center tapped and it is tapered. Next is four diodes, something that it acts as a normal transformer. Let us see in detail. So see in this diagram where when D1 conducts, D2 is off and the current flow through the load, and when D2 conducts, the resistor at when D1 conducts, the D2 will be off, the current flow at the load resistance, and vice versa. When D1 is off, the D2 will be on, so that the lower same current flow to the load resistance in opposite directions. So both the half waveform has been appeared pulses at the output. So in this circuit diagram, the secondary windings has been center tapped. Okay, that means which is grounded. So each diodes work alternatively, so that D1 conduct where D2 is off, and D2 is conduct when D1 is off, so that the full waveform has been produced. So next, let us see about during the positive half cycle of the alternative current, the top of the secondary waveform becomes positive, while the second half of the secondary winding becomes negative. And during the positive half cycle, the diode D1 is forward bias and it is connected to the top of the secondary winding, whereas the D2 is reverse bias, it is connected to the bottom of the secondary winding. When the diode D1 will conduct, act as a short circuit, and D2 will not conduct, acting as an open circuit. And during the negative half cycle, the diode D1 is reverse bias and also diode D2 is forward bias. Because of the top of the secondary circuit becomes both negative, the bottom is become positive. So this is the diagram, shows how the center tap full wave rectifier acts. And next is how the bridge rectifier acts. This is a diagram for bridge rectification, where this is second type where the four diodes are connected. So in this first half, positive waveform has been generated, and second half the negative waveform has been generated. So here the center tap transformer, it is a normal transformer with one slight modulation. Here additional wire is connected to the extra centered secondary winding, whereas it is grounded. So here the AC voltage into two equal positive and voltages, that is positive VN for positive VB. Next, let us see about the voltage which we get is V equal to VA plus VB. And next is the working of center tap full wave rectifier. Here when we apply our AC voltage to the input transformer, during a positive half cycle of the AC voltage, the terminal 1 will be positive and also center tap will be 0. So the terminal 2 will be in negative potential. So you will get a full waveform. So well, in power bias condition, the D1 will conduct and the current flows through the D1. During this, the D2 will be in reverse bias, which blocks the current. So in negative half cycle, D2 will conduct and D1 will be in reverse bias. So during the positive cycle, the diode D1 conducts, and during negative cycle, the diode D2 conducts during the positive cycle. So as a result, we'll get a full waveform. So here we are using a filter circuit in order to obtain a pulsating DC with many ripples. So we have to avoid filter the ripples. So here we are using a capacitor to filter the ripples, so that you'll get a good waveform. Let us see the formula for DC output. So here DC output equal to VDC equal to, you usually know that V equal to I into R. So VDC equal to IAB into RL. RMS value is equal to I max, maximum current, divided by root 2, and form factor is something that is equal to around 1.11, and peak factor for this full wave rectifier is around root 2. And this is the formula for rectification of DC output, efficiency, DC output power divided by AC output power. The efficiency compared with the half wave rectifier is around 81.2, where in your full wave rectifier is around 81.2, whereas in your half wave is 40.6. So its efficiency is extremely high compared with the half wave rectifier, and its ripple factor is around 0.4, and this for half wave rectifier is around 0.4. See, full wave rectifier is around 0.4, and for half wave rectifier is around 1.21. The only disadvantage of full wave rectifier is they need to more circuit elements than half wave rectifier. So let us summarize. Full wave rectifier, we saw about what is the definition of full wave rectifier and the types of circuit and its working principle and the formulas, and what are the main advantages and disadvantages compared with the half wave rectifier. So here efficiency is around 80.81% and ripple factor is 0.482, whereas compared to half wave rectifier, the ripples has been reduced by using of full wave rectifier, and the form factor is around 1.11 and P factor is around 1.414, and PIV for diode is 2V maximum. I hope you all understand this topic well, and try to solve these questions, and let us discuss about